This is the video for the preparation problems for the gas laws unit. The first question says 5.4 moles of gas are at STP. Determine all unknowns. So for this problem, we're going to find the value of each variable. One of them will not be given in the problem, so we'll have to pick the correct equation to find that unknown variable. If we look at the equation, the first given we see is 5.4 moles of gas. We don't see any other numbers, but I do see STP. So for moles, that unit tells me that's N. So N equals 5.4 moles. STP tells me two things. It tells me the temperature is 0 degrees Celsius and pressure is 1 atm. Remember that when you have a temperature unit in Celsius or temperature measurement in Celsius, you need to add 273 to convert it to Kelvin. So temperature is 273 Kelvin and pressure is 1 atmosphere. Well, we can put those numbers in the answer boxes for pressure, moles, and temperature, but we're still missing volume. So volume is our unknown. We need to pick an equation that will help us find volume given this stuff. Nothing is changing here, okay? So we don't have initial and final conditions. This is just a gas. It's just sitting there. And when you have a gas just at conditions and not changing, you're most likely going to use the ideal gas law. The ideal gas law is PV equals nRT. Well, let's see, we know P, looking for V. We know N. R is a constant. We always know R. And we know T. So PV equals nRT will work for this problem. I'm going to plug in. P is 1. V stays V. I have an equal sign. 5.4 for N. R is 0.0821. Because my pressure unit is atmosphere, R will always be that same number with this pressure unit. And T was 273. I multiply all these guys together. 1V is the same as V, and I get my answer is 121 liters. I can put that in my answer box. The next problem says a flexible container of gas is at 10 degrees and occupies 15.3 liters. The temperature changes to 40.7 degrees Celsius. Assume pressure remains constant. Determine all unknowns. We've got 10 degrees Celsius, 15.3 liters, and 40.7 degrees Celsius. So we can list out our givens. Let's see, first I have temperature 1, it's 10 degrees, but remember when you see degrees Celsius, add 273 and convert it to Kelvin. Liters is a volume measurement. So V1 is 15.3 liters. We've got to change. That means that our initial conditions are going to get labeled with a little 1. After the change, that's a temperature unit, so it's T2. So T2 equals 40.7 degrees Celsius plus 273. That gives me 313.7 Kelvin. I can put those numbers in my answer box, but look, I'm still unsure about V2. So that's my unknown. I need to pick an equation that tells me what happens when volume and temperature are both changing. That's Charles' law. V1 over T1 equals V2 over T2. Make sure to pick the right equation. Make sure to pick an equation that really exists. Sometimes people try and write V1 times T1 equals V2 times T2, but that's not correct. It's V1 divided by T1 equals V2 divided by T2. You plug in your values, and then you isolate V2, and you get your answer. In this case is 16.96 liters, and you can put that right there.